So the topic, D.2, string matching problem. So this is a, very basic computing problem. Very basic, string matching. When you do keywords-based search, you may need to use this basic algorithm, string matching. So first, let me describe the question. Yeah. All right. Our computing problem number 6, string matching. Yeah. Given a string of n characters, so we call it text. Yeah. A block of text. That's, we want to do keywords-based search. And a string of m characters, we call a pattern. So that's typically our keywords. Yeah. Here you can imagine only one keyword. If we have multiple keywords, we need to do one by one. Okay, one by one. Yeah. So then do some operations. So here you can assume the pattern corresponds to only one keyword. Yeah. M characters, m less than or equal to n. Yeah. The general question. Yeah. Then find a substring of the text that matches the pattern. Yeah. If you can find it, then you get a match. Otherwise, it's a miss. Yeah. No match. So then we, process other documents. Yeah. So here, the text part, we refer to one document, keywords-based search in one document. Yeah. All right. Yeah. So this is so you can see very basic computing problem. Yeah. Yeah. Here, we will use brute force method to solve. Very simple, brute force. You don't need any special technique. Just solve it using the, straightforward way. Yeah. Definitely, this way, the performance won't be very good. Yeah. If you want to improve the overall efficiency, you need to use more advanced algorithm. In our textbook, in later chapters, there is one very sophisticated algorithm solving this problem. Very complicated. Yeah, it's very hard to understand. Yeah. For this class, we will not go there. Okay, we will not go there. So if you are interested, you can read the details of that sophisticated algorithm solving the same problem. Okay, yeah, extremely complicated. Yeah. All right. Yeah. So here, the straightforward method, very simple. Yeah. So let's find the solution quickly. Yeah. All right. First, we need to do mathematical representation. Can you represent it using mathematical notations, symbols? So then we can do discussion. Yeah. All right. So let's do that part. Yeah. So we use, because for the given data, two parts, the text part and the pattern part. Yeah. And we use our data structure, we use array of characters to represent those two pieces of data. Yeah. So the first array of characters representing the text part. Second, the pattern part. Yeah. Two character array, one string. Yeah. So we can treat each piece has one string as one array of characters. All right, the first solution, straightforward, no. Mathematical representation. No. All right, yeah, because when we have good notations, then we can do discussion, we can go deeper, yeah. So we can use mathematical tools to do deeper analysis. Yeah. All right, the text, yeah. Let us use a sequence of variables, little t with subscripts from 0 through n-1. So that's the notation for the text part. Yeah. A string, an array of characters. Yeah. Each character has a location number. The subscript, it's a location number. Yeah. And the goal, we want to find the location of that matched pattern, substring, the matched location, that location. So what's that location? Yeah. The leftmost character, index I of the leftmost character, yeah, of the matching substring. That's the definition of the location of a substring. The first character, that location. All right. The pattern, we use little p, yeah, with subscripts from 0 through n-1. Yeah. Also locations. Yeah. All right. Matching, we do comparisons, character comparisons, one by one. Okay? Yeah. So now we need to describe the matching condition. Yeah. How do you check if you find a match? Yeah. So we need to check in this way. Yeah. Find the location I such that, yeah, in our processing, yeah, now we consider at the location I, we do character by character comparisons. The first comparison, ti equals p0. Second, yeah, ti plus 1 equals pi, and so on, dot, dot, dot. Okay? Yeah. And the general representation, ti plus j. Yeah, j. So j incremental. 1, 2, 3, 4 incremental. Okay? Yeah. So t sub I plus j equals pj. Incremental way. Yeah. And the last one, the last match for the character match, yeah, ti plus n-1 equals p sub n-1. Yeah. So if you check these m comparison, total number, m comparisons, if all true, all these m comparisons all correct, then you find a match. So you can return the location I number, you find the answer, or you find one match. Yeah. Okay, so if you want to find the second match, then you keep going. If you only need to find one, then your function terminates. That simple. Okay, all right, yeah. So that's our first round understanding. After we choose appropriate mathematical representation, so we do some, initial understanding. Next, we need to go deeper. We need to explore the properties. We need to Because the brute force method, straightforward, very simple. We need to prepare ourselves writing the code. Yeah, we want to implement it. We want to implement this algorithm. Character-based comparisons, very simple. Yeah. So now we are ready to write a program. Okay. Yeah. So here, I do not need to write program here, but I need to do one important thing. Think about when we write a program to do all these comparisons. Basically, we run a for loop, right? One for loop. Inside that for loop, we do all these comparisons inside that for loop. Yeah. So here, we only need to figure out the necessary information for writing that for loop. How to write that for loop? You need some information, right? Yeah, the for loop. Yeah. The starting point is easy. For loop start from 0, right? I equals 0. Yeah, starting from 0. But what is the end point? You need to figure out, right? How many comparisons? Yeah. You know, end location. Yeah. End location, we need to look at from the original text part, this part, location. Not in P. P from 0 and n minus 1. That's the end of in the P sequence, right? Yeah. So that's easy to see. But in T sequence, the starting location, the end location, we need to figure out. Yeah. Question?
So for the substring that we're looking for, does it always have to start at T0 in the original text? Or can it start
Yes.
at
T1? Yeah. No, right. So we scan from left to right. The first for loop starting from T0. Second from T1. Then T2 and so on. Okay? Yeah. So this is the brute force method. If yeah, I mentioned that advanced method, then it does not do this character by character shift because it's too slow, right? That advanced one, it can do some prediction. Yeah. Based on the comparison you do the first round, you may get some information, right? When you get some information and you use that useful information to do prediction, then you can jump. You do not need to do one character by one character shift. Sometimes you can jump faster. Sometimes jump slower. Sometimes faster. Yeah. So that's the advanced one. Yeah. But very complicated. In order to jump, so you need to, check a lot of conditions. Then you can jump. Yeah. Things like that. Yeah. So very complicated. Yeah. But here, brute force. So we do not do that. Okay. All right. Yeah. So the strategy. Yeah. So we are doing here. Guess and verify. Yeah. So this is another commonly used strategy in problem solving. Yeah, actually, we may use that before, right? We make a guess. Yeah, our guess could be wrong, so we need to verify it. Yeah. Here, yeah. So let's apply this simple strategy another time. Yeah. Later, we need to apply this strategy many times. Yeah. Simple but very effective. Yeah. All right. Yeah. So let's here the question. Yeah. Because the brute force, what do we basically do? We want to exhaust all M strings. Yeah. M string, each M consecutive characters or M substring. M substring. M consecutive characters in the original string. So that part, we call it M string. Yeah. The length of the substring is M. Yeah. So we want to exhaust all M strings, because in our for loop, we need to do the comparisons on all M strings. So we need to exhaust. Yeah. In that advanced algorithm, we do not need to exhaust because we can jump. Okay? So we can skip many M strings. But here we do not skip. So we need to exhaust all M strings. Yeah. All right. Every time, extract just one M string from the text with consecutive characters. Yeah, every time, yeah, we extract one, then we do comparison with the pattern one by one. Yeah? Straightforward. Yeah. So you know how to do the comparisons. Yeah. But you need to extract. Yeah. But you need to have, yeah, so here, basically you need to have a nested for loop. Yeah. Nested for loop. Outer for loop, inner for loop. The outer for loop, you need to go through all the M strings, right? In each inner for loop, you need to do, for each M string, you need to do comparison with the pattern, given pattern. Yeah. Character by character pattern comparison. Yeah. So it's a nested for loop. Yeah. The inner for loop, easy. Yeah. Yeah. Because we know the length M, so we, just do the simple comparison. But outer for loop, you need to figure out how many iterations do you need in the outer for loop. So here, we need to find that number. So you can write outer for loop. All right. Yeah, so yeah. Then step 2, that's for the inner for loop, right? So the first question we need to answer, how many such M substrings do you need for the outer for loop? Now, guess and verify. First, can you guess the number? Then we verify. So at the beginning, we make a guess. The closer, the better. So anyone, so you can, in your mind, you need to imagine, you need to visualize the situation. Okay, so you have a long text. You need to take a, M consecutive characters substring, so every time you take one, all right. Total, how many M substrings in that whole original string? Can you use M and N? N and M. Here you only have these two parameters. N number and M number. Yeah. Can you use these two numbers to represent the number of M strings? Think about it. We start from a beginning location at 0, then you chop first M characters the first time. So that's 1. Second time you shift to the right by 1 position. Start from index at 1 and take away M consecutive M substring. Second one. 2. When you start from 2, you take away M consecutive characters and keep going until you reach the end. When you reach the end, your rightmost character, you hit the last character of the text string. Yeah. In this way, imagine in this way. Okay? Yeah. How many? in your picture, in your mind. So visualize this, whole thing. Then, based on your intuition, because your line segment, you have some distance. When you hit the right end, there is some distance, right? Your starting point cannot reach the end, right? When you reach the last M substring, the starting point has certain distance from the right end, right? That distance, all right, you need to take away from the original string. Yeah. So here the intuition is important. In your mind, user intuition. You have a picture, okay? A picture, Yeah. Imaginary. All right? Then another try.
So is the index at 0 first?
Yes.
So is it n plus 1?
All right, so here. Yeah, start from N0, then you move one step by step toward the right end. But when you hit the right end, you look at the first character of the substring. Not look at your last character hit the right end. But you want to use the first character to look at its location. The first character has certain distance to the right end, right? That certain distance should be taken away from the original string. So it's a subtraction thing. It's a subtraction thing, okay? Original array has n characters, but you have certain distance. That distance looks like m difference, right? M characters. So it's very likely it's like n minus m. That picture, right? Minus, because you cannot hit the first character cannot hit the right end, right? That distance should be taken away. So that's a subtraction. So the first guess, let me write here. The first guess is n minus m. That's based on your intuition, okay? Yeah, picture in your mind. Yeah. You need to, draw a picture in your mind. Yeah. If you want to see better, you can do on scratch paper. Yeah, but this whole thing is very simple. Okay? So in your mind, okay? Yeah. Then, yeah. When you do the counting, you use the first character to do the counting, right? Yeah. The first character starts from the very beginning, but it cannot reach the end, right? The first character. The first character, when the whole substring reach the end, that means that its last character hits the end. Then when you need to go back, backtrack a little bit, right? Because you use the position of the first character, so you need to go back, backtrack a little bit. Backtrack about m characters. So that's why n minus m, okay? But this is a rough estimate. Yeah. May not be accurate, yeah, but pretty close. So that's the meaning I want to show you, this guess and verify strategy. Yeah. This guess is very rough. Not accurate. So we need to verify it. Okay? Otherwise, it could be wrong, right? So we want to verify it. Yeah. After your guess, try to find a way to verify it. Otherwise, you may get a wrong number. Yeah. Here, let's do the verification. Yeah. Do you have an idea how to do the verification? Yeah. So it's another important step in problem solving. How to do the verification. So when we do the verification, we try a simple example. We do experiments, but we do not do very complicated experiments. We do simple experiment. Can you imagine a special case for this problem? Let's start from the simplest possible case. Can you think of a very simple comparison case? The simplest case is m equals n. The text, the length of the text is the same as the length of the pattern. That's possible, right? That's allowed, right? When m equals n, how many m substrings can you find in the text? How many m substrings? When m equals n, the same. One, yeah, only one, yeah, only one possibility, okay? So the answer, that means here, use this simple example. When m equals n, the answer should be 1, okay? But if you use this guess, m minus n is 0, right? There is a difference, right? One difference. That means your guess is 1 away from the true answer. Your guess is not that accurate. Your guess pretty rough. How rough? 1 away from the correct answer. How to fix that? You need to fix it, okay? Fix your guess, right? Yeah. How to fix it? +1, you fix it. Yeah. Right? Because one difference, right? Yeah. So to fix your guess, 1 away from the true answer, yeah. So this is your guess. Yeah. But you check the case, you check this simple case. Okay? If you use this, your guess, you get 0, but you know the true answer is 1, not 0. So based on that experiment, that simple experiment, you need to fix your guess, adding that 1. So now you get a final answer. The correct number should be n minus m plus 1. Okay? Yeah. So here I use the simple example to, explain this strategy, this simple strategy. Okay? So later we will use this strategy many times in our problem solving. Okay? Yeah, guess and verify. Yeah. Yeah. But first, if your guess is far away, then it is harder. Yeah. So when you make your guess, you should make your guess as close as possible to the final answer. Then you only need to do small adjustment. Okay? If it's far away, you need to do big adjustment. Then it's very hard, right? Yeah. All right. Yeah. So we finish this one. All right. Next, implementation details. Yeah, here, let me use this diagram. So we run the for loop. Yeah. So we want to, because every time we want to extract one m substring, take away one m substring. Okay. So we need to figure out what is the starting point of the m substring. What is the end point of the m substring? All right. So then we can take the right part. Okay. Yeah. You do not take more characters. You do not take fewer characters. You want to take away exact number of characters. Okay. So we need to fix that technical problem. Then we can write our code. We can write nested for loop. Yeah. All right. So let's solve that technical. The first m substring. Yeah. So we know the starting location at 0 and end location at n minus 1. That's the first one. That's easy to see. Okay. All right. Yeah. Yeah. So when I equals 0, so we take away this many characters to do the comparison in the inner for loop. All right. Then, what's the last one? Yeah. So we want to see, yeah, for the last M substring, this location, we need to figure out, right? Yeah. That location, we need to figure out. Yeah. The question mark, yeah. The subscript, that one, we need to figure out. Okay? Yeah. So here, although it's not a hard question, yeah. Yeah. But here we need to use a simple way to figure out, right? Yeah. You need to do some work to figure out. Yeah. So here the question. What is the right way to find this number, the question mark, that number, the subscript, and the question mark? Yeah, yeah. So here, yeah. Although you may have different ways, yeah. Here I want to use a special way to let you figure out, yeah, how to find the number at the question mark, the subscript at the question mark. Okay, all right. Here, I want to remind you, we learned one problem-solving method before. So here we need to bring it back, okay? Practice that idea another time. Yeah. So remember, in our chessboard question, yeah, in our first class, chessboard question, okay? Yeah. Remember, m plus n equals 9, chessboard questions. Do you still remember chessboard question? M by m, the size, right? Yeah. So m by m squared. Then the number of squares of this size, m by n number of squares, right? Yeah. And then we find a property, the key critical property, m plus n equals 9, right? In the chessboard. And we call this concept, there is a concept, invariance, right? Yeah. So then we use a invariance. Invariance concept. Okay? Invariance. This 9 is invariance concept. When you change m and n, this 9 never changes. It's invariance. Here, let's use this invariance concept to help us figure out that question mark number subscript. Okay? All right. So here, think about when you move that m subscript from left to right, every time you move one position to the right, so it's a moving substring, right? Your substring keeps moving, okay, step by step, keeps moving. So it's changing, yeah, changing, all right? When your substring, you know, the information of your substring keeps changing from left to right, what quantity does not change during the moving? There is some property, never changes when you move the substrate from left to right. Yeah. Is there anything that never changes? Yes, the length. The length of the substrate never changes, right? So we use the length of the m substring as the invariance. What is the length? What is the length? Oh yeah, yeah, it's m, right? It's correct. The length is m, yeah. But for convenience, yeah, although the length, we can use the length, but for convenience, can we use another concept similar to length, but slightly different, but equivalent? Yeah. We use the subscript of the last character to subtract the subscript of the first character. How about that? That's slightly different from length, yeah, but equivalent, right? Yeah. And this difference never changes, right? Yeah. Let's use this as the invariance. So when you move your m substring, if you use the last subscript to minus the first subscript, the number should be fixed. The number here in the first one, it's n minus 1, right? So that invariance is n minus 1. It's fixed. So use that information to help you figure out that question mark number. All right. Yeah. So let us write that equation. Yeah. The difference of 2 and subscripts of each substrate. That's a fixed number. That fixed number is n minus 1. So we can set up a simple equation. The equation is, yeah, so here, the last subscript, that is n minus 1, right? The first subscript, the question mark, we use x to represent the first question mark number, okay? Then we take the difference. That difference should be the same as n minus 1, the first n substrate. We get that, first n substrate. Then this equation is very easy to solve. M equals n minus m. N minus m. That's x, okay? Yeah. So you find the location of the last m substrate. You find the location, okay? Yeah. So this method, yeah. Although simple here, very simple, but I want to refresh your memory about this invariance method. Okay, yeah, very useful. Yeah, very useful. So we review this method. Yeah. Yeah. So here you can see in this simple problem, we learned 2 methods. One, the strategy guess verify. That's one. Second, we review this invariance method, okay, in problem solving. Yeah. All right, so after that, then the remaining, I think, we have all the necessary information we need to write a for loop, nested for loop. Yeah. So here, I do not need to write it out, okay? Yeah. All right, so then let's do some analysis. Yeah. All right, the analysis, what's the best case efficiency? How many character comparisons do you need to do for the best case efficiency? Correct. M. Yeah, the first M substring, you get a match. Yeah, the best case. Okay. All right. What's the worst case efficiency? How many character comparisons you need to do? Yeah. All right. M times the number of M substrings, right? Each M substring, you need to do M comparisons. Then total, you need to do the multiplication. M times the total number of M substrings. Okay, all right. Then, can you tell me what's the average case efficiency? Average case efficiency? Here? Yeah. Can you do a simple average here? Best case plus worst case, there, divided by 2. Can you do it? Yeah, you can do it. Because here, the relationship is linear, right? Yeah, yeah, yeah. Because each M substring has the same probability here, okay? So, yeah, same probability, yeah. The contribution of each substring to the whole problem, the same. In this situation, you can do that simple average. Yeah. Yeah. If it's not the simple way, yeah, sometimes, the contribution of each subcase is different. Then you cannot use it this way. Here, the contribution of each the same. Okay, it's a linear. Yeah, linear. Yeah, so that's important. All right, so we finish this topic, and we've also finished module 2. Yeah. Next, let me jump to Module 3, and we do a short introduction. Yeah. Short introduction. Part A, Introduction to Recursive Algorithms. 8.1, First View of Recursive Algorithms. All right. Recursive thinking. Here. So let's look at the, when we do in order to implement your recursive algorithms, we need to do recursive thinking. Yeah. All right. So what's that? Yeah. Why recursive thinking is important in problem solving. Yeah. Here we, from the problem solving point of view, to understand recursive algorithms. Yeah. In problem solving, yeah, why it is a powerful method. Recursive algorithm, it's a powerful problem-solving method in problem solving. Yeah. Yeah. Because if you do not get a training, yeah, practicing this recursive algorithm, so people are used to straightforward non-recursive thinking. Yeah, non-recursive, that's straightforward. Yeah. So yeah, people are used to step by step. Yeah. The recursive, you call some recursive function, right? Yeah. So something hidden in the recursive function call. Okay, when you make a recursive function call, yeah, all the details are buried inside that recursive function call. Okay? Yeah. Some people, if they cannot see the details inside that recursive function call, then they may not feel comfortable. Yeah. So for those people without recursive training, yeah, yeah, here we need to get used to the recursive thinking. Yeah. Yeah. So we don't worry about the detail buried inside the recursive function call. Okay, yeah. So we will feel comfortable. Yeah. After we understand how it works, this whole method, how it works, then we will feel comfortable. Do not worry about the details inside that recursive function call. Yeah. All right. Some problems can be solved both non-recursively and recursively. Yeah. So, based on your experience, sometimes you solve the problem without using recursion. Yeah. But sometimes you like to solve the problem with recursion. Yeah. 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 Do you want to compare the difference? There is some difference. And sometimes one problem can be solved in both ways. Yeah. Non-recursive way and a recursive way. Yeah. So do you want to see how different these two methods? So here, let's do a simple comparison. Yeah. Look at advantages and the disadvantages of these two different ways. Yeah. All right. Yeah. Yeah. Then, to answer your question here, so why recursive thinking is important? The most important reason is because of this, the power of recursion. It's very powerful. This method is. Yeah. Why? Problem solvers, they sometimes, I want to say sometimes, they want to use recursive algorithms because they want to use the power of recursive algorithms. Yeah. So we will understand. In our second topic, we will look at the power of the recursion. Yeah. All right. Some relatively hard problems can, parenthesis only, yeah, because some people may have different opinion, yeah, can be solved by recursion. Yeah. Yeah. So that means for some hard problems, if you want to solve it without recursion, that could be very hard. That could be very hard. Yeah. Yeah. In 8.2, our 8.2, next topic. Yeah. So you will see, if you do not use recursion, it is extremely hard. Yeah. Yeah. Most people cannot do it. Okay? Yeah. All right. Now let's do comparison. Compare these two methods. Yeah. Non-recursive, recursive. Non-recursive method, we call it iterative method. Now, you do iterations, so it's an iterative method. Recursion, recursive. Yeah. Yeah. These two basic methods. Yeah. Advantage, disadvantage. Advantage for iterative, less resource. So here the less resource, typically we mean the memory resource. Memory storage resource. It uses less memory. Iterative method use less memory resource. Main memory. Yeah. Main memory. Yeah. RAM. Okay. RAM resource. Okay. That resource. Yeah. In main memory. Yeah. Yeah. All right. But harder implementation. Iterative usually, sometimes if you want to avoid recursion, then you may need to do a lot of work. So harder implementation. Yeah. But for recursive method, in order to, so here, the high-level language, because when you do recursion, you apply high-level programming language, right? Yeah, Java, C++, Python, they all support recursion. Yeah. So those programming languages, they need to do something special in main memory to support recursion. Yeah. The way they do to support recursion, that may take a lot of memory resource in your main memory. Yeah. So that one, hidden, you cannot see it. Yeah. But that happens behind the scene. Yeah. Yeah. So I will explain. Yeah. So that part behind the scenes, I will explain. Yeah. Soon, quickly, all right. So here, let me explain. So let me see how much time do I have. I have about 10 minutes. So let me explain why for recursive method in the high-level language, here we're talking about high-level programming language. We know the modern high-level programming language all support recursion. All right. So here, let's look at the implementation of recursion, but not by our programmers, no. In high-level programming language. All right, so that implementation, okay? Let me explain that idea, basic idea. So in order to implement recursion, it uses a special data structure, stack data structure, In your data structure class, you learned that stack data structure, right? So a stack like this data structure. And you push data item to be processed one by one into the stack. Okay, so this is the stack data structure. The stack has the property, first in, last out property, right? The first item you push in is at the bottom, okay? The first, second, third, and so on, okay? The first in, last out, okay? So people use FILO, okay? First in, last out, okay? Another, sometimes people say the last in, first out, okay? The last item you push in, and it's the first one you get out, okay? So that's the property of a stack, okay? Yeah. But to implement a recursive function, then the stack data structure is used, okay? Yeah. So here, let me describe how to use that stack, okay? All right. All right, so when we start, okay, all right, think about when we need to evaluate a function called f of n, okay, you call recursive function f of n, yeah. Then the value, its value is not available, because recursive, the first time you call it, it's not available. You need to do a recursion. Yeah. The first time fn not available, how do you do it? You push it into the stack. So f of n is at the bottom of the stack. Okay? Yeah. Then you call recursion. This function rely on f of n minus 1 to give you the answer. Okay? So then you need to look at the value of f of n minus 1, but it's not available. Okay? F of n minus 1 still not available. How do you do it? You push it into the stack, f of n minus 1, okay? If it's not available, you push into the stack, okay? Yeah. All right. Then, it rely on the value of fn minus 2, still not available, you push it into the stack, okay? Minus 2. Then, in this way, the last one, let's say f of 1. F of 1, suppose it's not known, you're pushing the stack. Then you need to use f of 0. F of 0, initial value, usually it is given. You have f of 0 given, you do not need to push into the stack. You use the f of 0 value, you can calculate f of 1. You can use f of 1, you can calculate f of 2. F of 2, f of 3, one by one. At the end, you'll find the answer at the bottom. That's the way to do the recursion using a stack. Okay? Yeah. When you do calculation, you calculate from top. Yeah. When you have f of 0, then you can calculate f1. F of 1. You pop it out. Pop out f1. Okay? Do the calculation. Then, after you have the value of f1, you can pop up f of 2. Then you do the calculation. Every time you pop up 1, the top item in the stack, you do the calculation, okay? Until you reach the bottom of the stack. You finish processing the whole stack. That's the typical way that a high-level programming language uses to implement recursion, okay? But in this way, the stack consumes a lot of memory resource. Okay? Yeah. Because for iterative method, you do not need to use the stack. Okay? So the resource used, not much. Okay? Not much. Yeah. But for the recursion, you need to maintain possibly a big stack. Yeah. So then there is a potential problem. Yeah. Sometimes if you do implement recursive algorithm, you may get a problem called a stack overflow problem, runtime error. you may get, so your program, stops working with a runtime error. Okay, you may have that situation, runtime error. Okay, sorry, runtime error. The runtime error, you can see the message. It's called a stack overflow. Your stack takes too much memory resource, and you run out of your memory resource. Your computer, the memory resource of your computer runs out. You don't have that much memory resource, so you run out of memory resource. So you get the runtime error is called stack overflow. When that happens, your program is killed. Then stop working, it's killed. Okay? Yeah? So you may need to find a way to solve the stack overflow problem. Okay? Yeah? So that problem. Okay? Yeah. For our class, when you implement recursion, if you apply it on a very large amount of data, you may get this kind of error. Okay, you may see it. Okay. Yeah. All right. So that's the introduction part. Yeah. Today I only do the introduction. Okay. Only do this initial introduction. Yeah. Next we have our first recursion problem. Problem number 7. Calculate the factorial. Yeah. So let me leave to next time. Okay. Yeah. Factorial, although simple, but we use it to help us understand the recursion. Yeah. So that's the reason we work on a very simple example. Okay, factorial. Yeah. You don't have to use recursion to calculate factorial, right? Yeah. You can calculate it directly, but here we just understand the basic procedure of recursion. We use the simple example to understand. Yeah. All right, yeah, that's it.